Local LLM infrastructure and resource optimization. The eternal struggle of running large language models locally has always been a battle against VRAM constraints, but a new approach from an unnamed startup demonstrates how creative engineering can stretch hardware far beyond its apparent limits. The team indexed the entire Llama library, representing over 10 terabytes of VRAM requirements, and claims to serve all models from a single 8-GPU H100 node using NVMe swapping rather than persistent GPU residency. The numbers they cite are genuinely interesting. Sub-70B models load in approximately 1.2 seconds on a single GPU, while behemoths like DeepSeek 671B or Llama 405B load across all 8 GPUs in roughly 2.5 seconds. This flash loading approach trades latency for cost efficiency, enabling serverless pricing models for the long tail of models that would otherwise require dedicated $50,000 per month H100 allocations. The community response, predictably, ranged from skepticism to enthusiasm. Several commenters noted the evasiveness around the "we" in question. Turns out it's a startup experimenting with Lambda-like infrastructure for LLMs. The fundamental insight here is that SSD capacity stopped being the constraint years ago. The real bottleneck is GPU memory residency and the economics of idle hardware. Whether this specific implementation gains traction remains to be seen. But the architectural pattern, treating model loading as a fast swap operation rather than a persistent allocation, represents a meaningful shift in how we might think about inference infrastructure. Meanwhile, the question of whether the next leap in AI will be architectural rather than merely scaling existing approaches continues to percolate through the community. A discussion around energy-based models for reasoning tasks highlights how different architectures create fundamentally different hardware demands. While standard transformers are VRAM and memory bandwidth bound, loading weights and managing massive KV caches, EBMs shift the bottleneck toward pure compute by treating inference as an iterative optimization problem. For the dual 3090/4090 crowd, who have decent flops but limited VRAM, this could theoretically be good news. Though the consensus suggests training stability and scalability remain unsolved problems despite LeCun's decades-long advocacy. For those wrestling with more immediate concerns, a new open-source tool aims to take the guesswork out of hardware planning. Local Inference Calculator evaluates whether specific model and GPU combinations will work at given context lengths, factoring in VRAM, KV cache, and overhead calculations. Community suggestions for improvement include estimating prompt processing and token generation speeds, calculating optimal layer offloading configurations, and packaging the tool as a single-page web application, all reasonable asks for what could become a standard planning utility. On the more ambitious end, a project called Remember Me AI claims zero hallucination guarantees through something called quantum dream memory architecture, terminology that should set off alarm bells for the technically literate, though the underlying goal of efficient local memory management for LLMs is legitimate even if the marketing language is not. AI agent development and multi-agent systems. Anyone who has experimented with multiple AI coding agents working on the same codebase has encountered the coordination nightmare. One agent refactors authentication, while another updates the login API. Neither aware of the other, resulting in merge conflict hell that wastes hours of work. A developer frustrated by this exact problem built SpiderSan, an open-source CLI tool that functions as a traffic controller for AI coding agents. The tool works with any agent capable of running CLI commands, Codex, Claude Code, Gemini, or local Llama variants, and attempts to prevent the chaos of uncoordinated concurrent modifications. The author's challenge to try it with 20 agents on the same file speaks to both the ambition and the genuine difficulty of multi-agent coordination in real codebases. The broader ecosystem is also seeing standardization efforts that could make agent coordination more tractable. Mintlify has introduced Skill.md, an open standard for describing how AI agents should interact with documentation and products. The insight driving this work is that documentation is written for humans who browse and gradually absorb information, but agents need concentrated, up-to-date context to perform effectively. Skill files can be installed into over 20 major coding agents and contain decision tables for tribal knowledge, the kind of implicit preferences that experienced developers carry but rarely document. Rather than scattering capabilities across dozens of pages, Skill.md consolidates them specifically for agent consumption. On the training side, LinkedIn's AI team has documented their experience enabling agentic reinforcement learning for the GPT-OSS model series in collaboration with the Veril framework community. Agentic RL extends traditional LLM training by optimizing entire decision-making processes through direct environment interaction rather than single-turn responses. The distinction matters. Agents must plan actions, invoke tools, observe outcomes, and adapt behavior over multi-step trajectories where intermediate choices, query reformulation, tool selection, execution order, directly influence downstream success. LinkedIn's context is particularly demanding, requiring models that reason over incomplete information, interact with structured services, and support multi-step workflows for recruiters, job seekers, and learners. Their practical retrospective covers integration challenges with GPT-OSS's Harmony chat template and verification through tasks like Retool, where models solve math problems with code compiler assistance. Code development tools and programming assistance. The intersection of semantic search and code navigation is producing tools that could fundamentally change how developers explore unfamiliar code bases. grep AI, a Go-based CLI tool, uses Allama's Nomic embed text model to replace traditional regex grep with semantic code search. The motivation is straightforward. Standard grep finds text matches but misses context, while semantic search understands what you're actually looking for. By running entirely locally and respecting gitignore, grep AI builds project indexes without code leaving the developer's machine, addressing both privacy concerns and API costs. The benchmark results deserve attention. When used as a pre-filter for Claude Code, grep AI reduced input tokens sent to the LLM by 97% and cut costs by 27.5%. The mechanism is simple but powerful. Let local embeddings decide which files are relevant before sending anything to the cloud. Even if you're not using Claude, the demonstration shows how effective local embeddings can be for RAG applications in code contexts. Community members are already suggesting alternative embedding models like Qwen 3 embedding 4B, GGUF, Q5KM for potential improvements. Anthropic is preparing to launch Phase 2 of Claude Code's Security Center, extending work that began roughly 6 months ago with CLI and GitHub Actions integration. The new iteration adds a centralized dashboard for security scans, issue tracking, and cross-repository visibility. Manual repository and branch scans combined with organization-level oversight represent a clear shift from developer-only checks toward a full security management layer, an acknowledgement that AI-assisted coding tools need enterprise-grade security controls to achieve serious adoption. Perhaps the most intriguing development in programming interfaces is voice-only programming. Pipecat's MCP server enables voice conversations with Claude Code from anywhere, using DeepGram for transcription and Cartesia for text-to-speech. The demo shows Claude performing front-end web testing, encountering an issue, receiving verbal input, and reporting test success, all through voice interaction. The underlying infrastructure supports any MCP-compatible client, with WebRTC as the general transport, but phone calls as an option for those who want to literally call Claude. Screen capture support allows remote viewing of the Claude Code window, though that feature remains experimental. The permission model requires thought. Hands-free voice conversations need auto-approved tool permissions, which introduces security trade-offs that the Pipecat skill attempts to mitigate by asking for verbal confirmation before file modifications. Qwen model family releases. Alibaba's Qwen team continues its rapid model expansion with 2 significant releases targeting specialized use cases. Qwen 3VL Ranker 2B extends the multimodal retrieval pipeline by providing high-precision re-ranking capabilities that complement embedding models. Built on the Qwen 3VL foundation, the re-ranker accepts diverse inputs, text, images, screenshots, video, and arbitrary combinations, and outputs relevant scores for query document pairs where both query and document may contain mixed modalities. The architectural philosophy here is worth noting. Retrieval pipelines typically benefit from a two-stage approach, where embedding models perform efficient initial recall at scale, while re-rankers refine results with higher precision in a subsequent stage. This division of labor acknowledges that dense retrieval and precise ranking require different optimization objectives. The Qwen 3 VL re-ranker inherits multilingual capabilities supporting over 30 languages, making it suitable for global applications. Practical features include flexible vector dimensions, customizable instructions for specific use cases, and strong performance even with quantized embeddings, details that matter for production deployments where memory and latency constraints are real. The Qwen 3 TTS system represents an equally comprehensive effort in text-to-speech, covering 10 major languages with multiple dialectal voice profiles. The technical claims are ambitious. The Qwen 3 TTS tokenizer 12 Hz achieves efficient acoustic compression while preserving paralinguistic information and acoustic environmental features through a discrete multi-codebook language model architecture. The most practically significant feature is the dual-track hybrid streaming generation that enables first audio packet output immediately after a single character is input, with end-to-end synthesis latency as low as 97 milliseconds, meeting the rigorous demands of real-time interactive scenarios where users expect near-instantaneous voice responses. The model family includes both 1.7B and 0.6B parameter variants. The larger models support voice design from user descriptions, style control over target timbres with 9 premium voices covering various gender, age, language, and dialect combinations, and a base model capable of 3-second rapid voice cloning from user audio input. The 2.6B base model provides an entry point for fine-tuning custom applications. Natural language instruction support enables flexible control over timbre, emotion, and prosody, with deep text semantic understanding that allows adaptive adjustment of tone, rhythm, and emotional expression. Model fine-tuning and embedding technologies. The gap between training powerful embedding models and actually using them in production has always been a friction point for practitioners. But Unsloth's announcement of embedding model fine-tuning support could significantly lower that barrier. Daniel Hand's announcement claims 1.8x to 3.3x faster training with 20% less VRAM compared to standard approaches, with compatibility for embedding Gemma, Qwen 3 embedding, and other models through integration with sentence transformers. The 6 provided notebooks demonstrate customization for RAG, semantic similarity tasks, and related applications. Given Unsloth's reputation for efficient LLM fine-tuning, expectations are reasonably high that this will meaningfully improve the retrieval model fine-tuning experience. The timing aligns with growing recognition that generic embeddings leave significant performance on the table for domain-specific applications. RAG systems in particular benefit enormously from embeddings trained on the actual document types and query patterns they'll encounter in production. The combination of Unsloth's optimization techniques with sentence transformers' established training infrastructure could make custom embedding models more accessible to teams without dedicated ML engineering resources. In the vision language space, DeepSeek has released DeepSeek OCR2, which the company positions as the first vision AI that reads documents with human-like logical understanding rather than rigid grid scanning. The core innovation in the DeepEncoder v2 architecture is understanding logical flow, reading columns in order, linking labels to values, and handling complex diagrams without hallucinating. At 3B parameters with MIT licensing, this represents a significant shift in the economics of enterprise OCR, which has traditionally been a high-margin business, with vendors charging tens of thousands monthly for document processing. The practical question is how it compares to alternatives like GOT2, EasyOCR, or Mini-CPMO 2.6 in real-world applications. Early observations suggest Chandra excels at handwriting, while Light Onaker 2.1b performs well on tables, indicating that model selection for OCR remains task-dependent despite claims of general superiority. AI research and novel architectures. The computational expense of chain-of-thought reasoning continues to drive research into more efficient alternatives, and multiplex thinking from University of Pennsylvania and Microsoft Research offers a theoretically principled approach that could significantly reduce token costs while maintaining reasoning quality. The core insight is that humans often reason softly, by maintaining distributions over plausible next steps rather than committing to single discrete choices. Current continuous token approaches that attempt to reduce token costs are typically deterministic. Given next token logits, they map the distribution to a single continuous vector, which collapses the token-level policy distribution and makes decoded rollouts identical, limiting exploration. This determinism is fundamentally misaligned with reinforcement learning, where on-policy stochastic rollouts are crucial for effective trial-and-error learning. Multiplex thinking addresses this by sampling k-candidate tokens independently from the model's token distribution at each reasoning step and aggregating their embeddings into a single continuous multiplex token. The paper explores two weighting strategies, uniform averaging and LM head reweighting, that reflects model confidence over sampled candidates. A critical property is self-adaptivity. When the model is confident, the approach behaves more like standard decoding. When uncertain, it maintains broader exploration. The practical implications for training efficiency could be substantial if the approach scales, though production deployment would require careful validation. On the applications side, Meta's Action Mesh demonstrates sophisticated integration of AI with traditional 3D graphics workflows. The video-to-animated mesh model generates animated 3D meshes from input videos in under a minute, with output seamlessly importable into Blender and other 3D software. Hardware requirements are steep, 32 GB of VRAM minimum, tested on A100, H100, and H200, but the capability represents genuine progress in bridging AI generation with professional creative pipelines. The workflow handles 8 to 16 input frames, applies automatic background removal if masks aren't provided, and exports per time-step mesh files along with alembic animations. DeepSeek's Ngram project explores a different architectural direction entirely. Conditional memory via scalable lookup as a complement to mixture of experts conditional computation. The core idea is that transformers lack a native primitive for knowledge lookup, and Ngram instantiates this through modernized Ngram embeddings. The researchers identify a U-shaped scaling law that guides optimal capacity allocation between neural computation and static memory. With their 27B model demonstrating improvements over MoE baselines across knowledge, reasoning, code, and math domains under strict isoparameter and isoflops constraints. The analysis suggests that Ngram relieves early layers from static pattern reconstruction, potentially preserving effective depth for complex reasoning, a hypothesis that, if validated, could influence future architecture design. AI ethics and geopolitical implications. A recent paper from Boston University School of Law takes an unusually civilizational view of large language models, examining not how well they code, but rather what having them around is doing to the sinews of civilization. The authors systematically identify key elements that make democratic institutions function effectively, then argue that each foundational pillar is being subtly corroded by LLM use. The concern is not immediate catastrophe from a local government clerk using ChatGPT, rather, a slow transformation of democratic structures taken for granted in the West. The paper includes a pointed observation that authoritarian leaders and technology oligarchs are deploying AI systems to hollow out public institutions with an astonishing alacrity. The community response to this analysis was predictably polarized. Some dismissed the authors as word-cell lawyer types, paranoid about replacement, hoping AI would automate lawyers, politicians, and CEOs entirely. Others warned about the limitations of AI decision-making with dark humor. If you thought human bean counters were bad, just wait until your proposals are shot down by management bots that literally can't count. A substantial thread debated accountability, questioning whether politicians can meaningfully be held responsible for decisions, let alone AI systems making analogous choices. The paper also apparently contains criticism of LLMs ruining higher education, a concern that seems increasingly mainstream as institutions grapple with assignment authenticity and learning outcomes. Meanwhile, European concerns about technology dependence on U.S. infrastructure continue to simmer. with calls to reduce reliance on American internet technology gaining political momentum. The strategic calculus is straightforward. Critical infrastructure controlled by foreign entities represents a vulnerability regardless of current political relationships. Whether Europe can realistically develop alternatives to established U.S. tech stacks, cloud infrastructure, AI platforms, social networks, remains an open question, but the political will to try appears to be strengthening. AI platform manipulation and bias concerns. The question of whether companies can hack AI systems to promote their products recalls the early days of SEO, when gaming search rankings became an industry unto itself. A Reddit user noticed ChatGPT recommending the same well-known note-taking apps, Notion, Google Keep, OneNote, rather than lesser-known alternatives, prompting discussion about how AI recommendation systems actually work and whether they can be manipulated. The technical reality is that LLM recommendations derive from multiple sources. Pre-training on internet data captures buzz around popular products and learns to predict how recommendation threads typically answer questions. RLHF and SFT modulate this baseline, and increasingly, search integration, Bing for GPT, Google for Gemini, Brave for Claude, introduces real-time ranking signals. Generative engine optimization, is already an emerging marketing field focused on improving product visibility to AI systems. Wikipedia even has an entry on it now. The concern that triggered the original question is legitimate. If AI recommendations can be influenced by marketing spend or deliberate manipulation, the value proposition of asking an AI assistant for advice degrades significantly. One commenter put it bluntly, if we start getting suggestions based on marketing, ad, SEO spend in natural responses, AI chat tools will be considered compromised and trust will drop significantly. A technical comparison document for RoovBot versus ClaudeBot personal AI assistants provides a window into how different architectural choices affect AI system capabilities. The claimed improvements are substantial: 75x faster embedding speed by eliminating network latency, 50x faster 10K vector search, and the ability to handle one-memon vector searches that weren't feasible before. The SONA, self-organizing neural architecture, learning pipeline introduces trajectory learning that enables continuous improvement with each interaction, fundamentally different from static rule-based approaches. The three-tier intelligent routing architecture, from near-instant free transforms through mid-tier haiku to high-complexity sonnet opus calls, represents an economic optimization that balances capability against cost. Whether these architectural claims hold up in practice requires independent validation, but the comparison framework itself illustrates the growing sophistication expected from personal AI systems.